Hello, I'm Anthony Vaughn with the product marketing team for Texas Instruments Hercules Safety Microcontroller Group. Today I'm going to introduce you to the Controller Area Network, or DCAN module, and show you how to configure it using HALCoGen, TI's tool for generating initialization and peripheral driver code for Hercules MCUs. Most microcontrollers in the Hercules platform integrate either 2 or 3 separate DCAN communication modules. One of the most common uses for the DCAN module is as a communications channel between electronic control units. Since CAN messages usually are transmitted beyond a single circuit board from control unit to control unit, the physical bus is most commonly comprised of a 2-wire twisted pair where differential signals are transmitted. The maximum length of a CAN network will depend on the data transmission rate. At the maximum data rate of 1 megabits per second, the max CAN bus length is 40 meters. Both ends of the CAN network should be terminated with 120 ohm resistors between the CAN high and CAN low signals. Because a CAN network is made up of CAN high and CAN low differential signals, a network interface transceiver is needed in between the digital CAN I/O transmit and receive pins of the microcontroller and the actual network. There are many CAN transceivers available from Texas Instruments. The transceiver integrated into the Hercules development boards is the SN65HVD232. For more information about this CAN transceiver, please visit the website ti.com/product/SN65HVD232. The DCAN module integrated into many Hercules MCUs implements the full CAN protocol versions 2.0A and B. The module is comprised of separate components that can be seen on this block diagram. The major components include the CAN core, the message handler, the message RAM, the register and message object access interface, and the module interface. I am now going to show you how to use HALCoGen to easily configure the DCAN module to perform digital communication between different microcontrollers. If you do not already have HALCoGen, you can download it from the Tools and Software area on the website ti.com/Hercules. HALCoGen can also be installed directly from the software DVD included in all Hercules USB development stick and Hercules development kits. In this exercise, we are going to set up the DCAN modules on 2 separate microcontrollers. Then we will send a CAN message from one MCU to the other one. Finally, we will send the data received in the CAN message to a PC terminal for viewing on the SCI module configured for UART communication. For this exercise, we will need a Windows PC and 2 of either the TMS570 LS31 or RM48 USB stick or either of the Hercules development kits. We will also need HALCoGen and CodeComposer Studio. To start the HALCoGen applications, go to the Windows or Start menu and select Programs, Texas Instruments, Hercules, HALCoGen. To start a new HALCoGen project, select File, New, Project. Once the new project window has opened, the device family and specific device information must be selected. The name of the project can be entered along with the location for all the generated code to be stored. So for this exercise, we need to generate 2 different HALCoGen projects and import them separately into CodeComposer, since we'll be using 2 development boards. The first step that we're going to do is we're going to have HALCoGen create us code for the CAN transmit. Inside HALCoGen, we need to first create a new project. To do this, we choose File, New, Project. The particular device that we're going to be using is in the family TMS570 LS31X. And then we choose the TMDX570 LS31 USB, and then we give it a name. We will call this DCAN_TX. Then we click OK. Then we can see a block diagram view of the chip. To configure this example, we first go to the Driver Enable tab, we unmark all drivers, and then we enable just the DCAN1 driver. Then the next step is to go to the CAN1 tab, and in the CAN1 General subtab, we make sure that our bitrate is set to 500. Then the next step is to go to the CAN1 message 1 through 8 and make sure that it is activated to transmit signals. That's the last step that we need to do in HALCoGen before we generate code. To generate code, we go to File and choose Generate Code. This will create all of the startup code and drivers that we need to transmit our CAN message. The next step is to create our CAN receive program. So we're going to create a new HALCoGen project for that. To do that, we choose File, New, Project. For this part of the project, we're going to be selecting the RM4 family and choosing the RM48 USB stick. Then we need to enter a name for our project, and we will call this DCAN _ RX. Then click OK. Then we will see a block diagram view of this microcontroller. The next step is to click on the Driver Enable tab, then click Unmark All Drivers, and for this project, we're going to enable the DCAN1 driver because we're going to receive messages through the CAN1 interface. And then we will also need to enable the SCI2 driver, since once we receive the CAN message in this project, we're going to send it to the PC using the SCI and UART mode. The next step is to go to the CAN1 tab, and in the CAN1 General sub-tab, check to make sure that our bitrate is also set to 500. Then we need to go to the CAN1 Message Through 8 tab and select Activate and change this one to Receive. Then the next step is to go to the SCI2 tab and go to the SCI Data Format tab and ensure that our baud rate is set to 9600 and our data length is set to 8 and that we have 2 stop bits selected and that parity is disabled. That's the final step in the configuration of HALCoGen before we generate code. To generate code, we go to File and choose Generate Code. We've now generated all the code necessary for our project. Now we need to go to Code Composer Studio. Inside Code Composer, the first step is to set up our project for the CAN transmit portion of the exercise. To do that, we choose File, New, CCS Project. Then we give it a project name. This one needs to match the name that we used in HALCoGen. So this one's going to be called DCAN _ TX. Then we need to go to the device variant and select Cortex-R, and then choose the device TMS570LS3137. Then for the connection, we need to choose the Texas Instruments XDS100V2 USB emulator. Then click Finish. Then we can see our project is viewable in the Project Explorer tab on the left side of the screen. The first step is to expand the project and delete the blank main.c file. Code Composer Studio will always create this dummy main file for us, but we will not use it since we're going to use the one that we created with HALCoGen. So we right-click on the file and choose Delete. The next step is to make some configurations in our project. To do this, we right-click on the top level of the project and choose Properties. In here, we need to first include all of our include files that HALCoGen created for us. So we click on Include Options, and then click Add, click on Workspace, expand our project, and select Include. Then click OK. The next step is to click on the Debug options and select TMS570LS3137 Flash Settings. And then in the Erase options, change this setting from Entire Flash to Erase Necessary Sectors Only for program load. This will make the erase process much faster for this project. Then click Apply, then click OK. The next step is to enter some code into our project. To do this, we expand the source area and then double-click on the sys_main.c file. This is where our main function is. This is where we need to enter code for our project. The first area of code that we need to enter is in the user code begin 0 section. What we need to do in here is we need to include our CAN header file. Then the next section goes in the user code begin 2 section. In here, we need to define some variables and actually set up the data that we're going to be transmitting through our CAN bus. So for this particular exercise, we're going to be sending the characters that spell out the word Hercules. The next section where we need to enter code is within our main function in the user code begin 3 section. Here we need to initialize our CAN module by calling the CAN init function, and then we need to actually transmit our CAN data by using the CAN transmit function. Then we go into an infinite loop, or a while one statement. The final section of code that we have to enter is going to be in the user code begin for section. This is where all the interrupts are handled in our program, as well as the area where we declare other functions. We're not using interrupts for this example, so all of the interrupt notification functions we're going to leave blank. We're now finished setting up this portion of the project. To compile and load it on the microcontroller, we choose Run and Debug. This will compile, link, and then program our code into the microcontroller. The next step in Code Composer is to set up the CAN receive section. To do this, we choose File, New CCS Project. Then we need to enter a project name. This name needs to match the same name that we defined in HALCoGen. So this will be called DCAN_RX. Then we need to set up the device variant to Cortex-R, and then we need to set the device name to RM48L950. Then we need to set the connection type to Texas Instruments XDS100 version 2 USB emulator. Then we click Finish. That will bring up our CAN receive project. We can minimize our CAN transmit project now. Now we need to make the same settings that we did to our CAN transmit project. So the first thing we do is delete our main.c file. And then we do the same property configurations where we select all of our include files, click on Workspace, choose CAN receive, select include, then click OK. And then in the debug section, select the flash settings, and then in the erase options, choose necessary sectors only for program load. Then hit apply and OK. Now we expand the source area, and we need to open the sys_main.c file. Inside here, we're going to be entering similar code. In the user code begin 0 section, we include a number of header files. The two most important ones are the CAN header file and the SCI header file. Then in the user code begin 2 section, we enter some other code where we set up our receive size for our data coming in the CAN peripheral. Then the next section is going to be in user code begin 3, which is in our main function. Inside this code, we initialize our CAN module as well as initialize our SCI module. Then we wait for a CAN message to be received. Once it's been received, then we send out that data on the SCI port. And then we go into a while one loop. The very last section will be in user code 4. In here, we put in the notification options if we were using interrupts, but this project doesn't use interrupts, so all of these will remain blank. The next step is to set up our terminal window. To do this, we choose View, Other, and select Terminal. Then we go into the yellow settings box within the terminal and select our COM port. We'll be using COM port 8, and then we need to make sure that our baud rate is set to 9600, data bits are set to 8, stop bits are set to 2, and parity and flow control are both set to none. Then we click OK. Then we will be connected to our COM port. The final step is to load our program. To do that, we choose Run and Debug. Once the flash memory is programmed on both of our microcontrollers, we can reset them by pressing the power on reset on the board. And then our CAN transmitter will send to our CAN receiver, and then on the terminal, we should see the word Hercules appear. We've now completed this exercise. There are a number of online resources available where you can go to get more information about Hercules microcontrollers. The first is the Hercules web pages that are on TI.com. Here you can download official device datasheets, technical reference manuals, and application notes. You can download software like HALCoGen, NowFlash, and the High-Timer Integrated Development Environment. You can also order development kits through the TI eStore from these web pages. The next online resource that is at your disposal is the TI Engineer to Engineer Support Forum. Here you can find the latest news and announcements about Hercules MCUs, in addition to searching for technical content about Hercules. There is a team of applications engineers available to answer questions posted to this forum. The final web-based resource is the Hercules Wikis. These sites feature how-to guides, introduction videos, and general information about Hercules MCUs. The wikis contain useful information like development kit, board schematics, and training content. I hope that you have found this video useful. Thank you for watching.